Good morning, pre-calculus. So here's where our course changes pretty drastically. Up until now, we've been doing a lot of algebraic functions and looking at a lot of algebra and more intense algebra. We've seen some new things along the way, but a lot of very familiar concepts, things that we've talked about in previous classes. Now we're going to start the trigonometry portion of this course. Trigonometry is a whole different branch of mathematics, and the rest of this course really focuses in on what it is and how we can use it. So there'll be a lot of new things coming up. Now notice, just because they're new doesn't mean they have to be hard, but trigonometry can be quite different. Hopefully you've seen some of it, depending on who you had for previous teachers. You saw some of it in your Algebra 1 and college algebra courses. But trigonometry is going to be a very different study. So we're going to start from the very basics. Everybody's going to know some things and other things you don't know. But I'm just going to start right from scratch here. I'm just going to start right from the very first concept. So, trigonometry, chapter 6. Now this word trigonometry, tri meaning three, gon is dealing with angles, so this is three angles, and whenever you see the metry suffix, it means measuring. So the word trigonometry literally means triangle measuring things with three angles. And we're going to start off with right triangle trigonometry. Most of the things will be right triangles, and then we'll kind of explore and go on from there. So it's all about relationships in angles. So let's take a look at angles. What is an angle? Now, an angle is defined as two rays with a common endpoint. So, for example, I could have ray AB, remember the symbol for geometry from a ray, and ray AC that have a common endpoint in A and therefore are forming this angle. Now remember the ways of naming angles. The A is the vertex, so I could call this angle BAC, or I could call it CAB, or I could just call it angle A, or I could put a number in here and refer to it as angle 1. Usually, what we're going to do now, instead of using numbers in here, we're going to use some symbols. The symbol we often use for an angle is going to be this. It's a Greek letter, and it's called theta. Theta, theta. That's going to be our unknown angle. We'll have other variables that we'll use. We'll often also use alpha and beta. The first two letters of the Greek alphabet, where we get our word alphabet from, alpha and beta. But theta is kind of like x, the unknown angle theta. And then if we've got multiple angles we're talking about, we'll talk in terms of alpha and beta or beta. So I want to take a look and get a little bit more precise about angles and how do we denote them, and a little bit more specific than you did in your geometry class. First, when we're talking about angles, we're often talking about angles in standard position. And if I think about an angle in standard position, I want to think about my x and y axis, and I'm going to have an angle where the vertex will be the origin and the angle will go off in some direction. I'm going to put this one off here into the second quadrant, and this is my angle. This is my theta, the angle. It has an initial side and a terminal side. And if it's in standard position, the initial side is the x-axis, and then I open it up to the terminal side, and this is where my angle is created. Now notice this is a positive angle, and I'm going counterclockwise. So the angles are being measured going this way, and it's a positive angle. I could have an angle going the other way, so theta here would be a positive angle in standard position. And let's see, a right angle is 90 degrees, a straight angle is 180. So this angle theta is somewhere between a 90 degrees and 180 degrees. But I could also have an angle that has, again, the initial side on the x-axis. But this time I could have a negative angle. It could go off in this direction. So here, measuring it this way, I could have a theta. And in this case, the theta would be a negative angle. And it would be going clockwise, starting again at the x-axis here and going clockwise would be a negative angle. Starting at the x-axis and going counterclockwise would be a positive angle. There's lots of ways of measuring. This is in standard position when it's along the x-axis. There's a lot of ways of measuring angles, two of the main ways. First, let's talk about the one that you know, the one that you're very familiar with. Measuring angles in degrees. Now, when we talk about measuring angles in degrees, and I'm going to draw a nice big circle here, and I'm going to look at going around the angle, looking at positive angles in standard position, where if I have this angle right here would be 0 degrees, this angle right here would be 90 degrees, this angle right here would be 180 degrees, and this angle would be 270 degrees, and all the way around would be 360 degrees. I've got some other reference angles that I can think about. I've got halfway here. This would be a 45 degree angle. Go another 45, I'm at 90. Go another 45, now I'm at 135 degrees. Another 45, 180. Another 45, now I'm at 225 degrees. Another 45 to 270. Another 45, and I'm at 315 degrees. I've got angles within those two. The reference angles that we want to pay attention to are every 30 degrees. So I could have an angle that's right about here, and again, this would be the angle, that's 30 degrees. In halfway between them would be 15, and then 45, and then an angle right about here, which would be 45 plus 15, 60 degrees. I'm ignoring the 15 degrees and the 75 degrees for right now. And then I've got an angle here. That would be 90 plus 30 would be 120 degrees. And here, 135 plus another 15 is 150 degrees. 180 plus 30, I've got an angle here. 210 degrees. Here would be 240 degrees, and then another 30 to 270, and then an angle here, oh dear, I'm writing on top of myself, would be 300 degrees, and then finally here would be 330 degrees. We often think of this as a circle with a radius of 1. We call it the unit circle. We will definitely get into that a little bit later. But these are our main reference angles. These are the ones that, if I say the degrees, you should picture where it is. And these are all in standard position, measuring from the x-axis going counterclockwise to the angle. Notice that all these angles are in different quadrants. I've got my 4 quadrants. I've got quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. So if I said, 210 degrees, that's a third quadrant angle. It's 210 degrees is 30 degrees below the axis. Or 270 degrees. Well, here's 270 degrees. What quadrant is 270 degrees in? Well, it's not in any. It's quadrant 3, quadrant 4. It's right there. It's on the axis. So we don't say that it is in any actual quadrant. All right, so as I look at these angles and I go around counterclockwise, I might actually go more than once around. And I want to talk about something called a coterminal angle. coterminal angles. Again, if I have an angle in standard position, let's say I've got a 45-degree angle, because that is 45 degrees. I could have another angle that's exactly the same as 45 degrees that would be this angle right here. Now watch this come out, because I'm going to start in standard position, I'm going to go all the way around and then stop right there. That would be the same angle. They would really be the same angle. But what would the measure of this angle be? Well, it's a whole circle, 360, plus another 45. This would be 405 degrees. These would be coterminal angles. They're really the same type of angle. Let me give you another example. I could have an angle of negative 60 degrees, and the coterminal angle this way would be 300 degrees. They are really the same angle, negative 60 degrees and 300 degrees. So there's lots of possibilities here. I can keep going around multiple times, just adding 360, and so forth, and or going backwards and forwards, positive and negative angles. Lots of angles end up being the same angle on our graph here. All right, the next concept should be one that we're very familiar with, the idea of supplements and complements. Let's talk about complementary angles. And of course, complementary angles are two angles that add up to 90 degrees. So if I look on my axis, and I just put in any angle here, and I've got angle alpha and angle beta, clearly the two angles add up to 90 degrees, so they would be complementary. I can also have supplementary angles. And in supplementary angles are two angles who would add up to be 180 degrees. So for example, if I had this angle alpha and this angle beta, these two make a straight line. A straight line is 180 degrees, so they would be supplements. So now let's take a look at actually finding some complements and supplements. So here I want to find complements, find the complement of the following angles. Find the complement of 48 degrees, of 135 degrees, and negative 15 degrees. And then we're going to find supplements. And I want you to find the supplements of the following angles. Same angles. We'll do 48 degrees, 135 degrees, and negative 15 degrees. All right, so let me pause for a minute, give you a chance to look at these and answer the questions, see what you think. I'll give you a minute. You don't have to pause the video. All right, let's take a look. So the complement, what angle added to 48 degrees would give me 90? The complement would be 42 degrees. What would be the supplement of 40? What added to 48 would give me 180? 132 degrees. How about this, the complement of 135? And I know a lot of you are thinking, oh, how about negative 45? It's a good idea, but no, it doesn't work. Since this is more than 90 degrees, there is none. It has no complement. The supplement would be, 45 degrees. How about negative 15? Well, again, the complement, you might be thinking maybe 105, because if I add the numbers 105 and negative 15, I get 90. But it's a negative angle, so it has no complement, and for the same reason, it has no supplement either. degrees can be broken down. 1 degree is equal to 60 seconds. The little tick mark indicates seconds. I'm sorry, minutes. 1 degree equals 60 minutes. And 1 minute equals 60 seconds. So let me make sure I've got this right. 1 degree is 60 minutes. 1 minute is 60 seconds. So we can break down degrees into minutes and seconds. We often refer to this as DMS. In fact, you have an app on your calculators to help you convert with degrees, minutes, and seconds. What I'd like to do, though, is I'd like to do it without the app, and we're going to do it just with a calculator so you can kind of see what's going on here. So if I have an angle, a very precise angle, given an angle of 23 degrees, 11 minutes, and 29 seconds. I want to convert this into a single number. I want to convert this into a rational number. Well, this is the same thing as 23 degrees and 11 out of 60, because there's 11 minutes out of 60 minutes in an hour, plus, now the 29 would not be out of 60, it would be out of 60 times 60, 3,600. So I can just do this do this computation on my calculator. All right, so here we go. So I'm going to do 23 plus 11 sixtieths plus 29 3600ths. And this angle as a decimal would be 23.19138 approximately. So converting, don't use the DMS. You do have the DMS button, but we can convert a lot quicker and easier this way. It's a little bit more interesting if we try to convert going the other way. So now let's take a decimal number and convert it going the other way. Suppose I have an angle that is 47.1825. And I want to convert that to degrees, minutes, and seconds. Again, you have an app on there to convert to degrees, minutes, and seconds. But this is going to be 47 degrees, and I'm going to write the word "and" here, 0.1825 minutes. I'm going to take the 0.1825 and multiply it by 60. So now I've got 47 degrees, 10 minutes, and 0.95 seconds. I'm going to multiply that by 60. And I've got 47 degrees, 10 minutes, and 57 seconds. So converting from decimals to degrees, minutes, and seconds, and from degrees, minutes, and seconds back to decimals. Important little skill. Degrees are only one way of measuring angles, and that's where we start because it's comfortable, it's familiar, but there's a much more important way that after this chapter, pretty much the only way we're going to look at angles is using a whole nother way of measuring it, and we have to think completely differently here. It's radians. Now I know you've seen radians before, and I know they're very confusing. What is a radian measure? The degree has a little symbol. For radian measures, we usually just abbreviate it as RAD. And the radian measure, degrees are part of a circle. 1 degree is 1/360th of a circle. But radians don't work that way. They work a little bit different. So I want to take a look at a circle. Now, in a degree, if I went 1/360th, that would be 1 degree. And 90 out of 360 would be 1/4 of the circle, and that would be a right angle. But here, I'm looking at the radius and the angle and the arc length. So the important parts for the definition of a radian measure is the radius here, which is the same as that, my angle here, which is going to be in radians in a moment, and this length right here, this length of the arc, which we're going to call S, which is the arc length. So the definition of a radian measure is the radian measure of the angle is the arc length divided by the radius. S is the length of the arc, and R is the radius. And you can probably guess why later the unit circle, where the radius is just 1, why that becomes so important. Because then the radian measure of the angle is just the arc length. All right, so let's take a look at that. Let's take a look at converting between degrees and radians and back and forth. So convert degrees to radians. All right, so theta in degrees is going to be the same thing as 180 over pi radians. Now, hang on there. I'm going to explain this in a moment. But going the other way, convert radians to degrees. Well, theta in radians, and we don't have a little symbol. This is theta in degrees. Theta in radians is pi radians over 180 degrees. So these are our unit conversions here. Well, what's going on? Why does this work? Well, let's take a look at the unit circle, which is just a circle with a radius of 1. Now, what is in degrees, 180 degrees, would be this measure right here, that angle. That would be 180 in degrees. But what would that be in radians? Well, remember, a radian is the length of the arc over the radius. The whole circumference of the circle is 2 pi r. If the radius is 1, then the whole circumference is 2 times pi times 1. The whole circumference is 2 pi. In other words, the radian measure, if I went all the way around, would be 2 pi. So what would be the radian measure if I just go halfway, 180 degrees, would just be pi. So this angle in radians would be pi radians. In other words, 180 degrees is equal to pi radians. All right, I'm going to pause right here, and then when we come back, we'll actually do a couple of conversions, and we'll take a look at some more unit circle and some practical applications of this. So I'm going to hit pause right here if you want to take a look at the first few problems in the homework. Right now there's really not much that you can do. We haven't really got into anything yet, but as soon as we get back we'll start doing some applications.